Okay, today we were talking about asymptotes, and the last question was asking about the oblique asymptote for a function where you have a degree higher on the top and lower on the bottom. I tried to take a shortcut with this using the methods with infinity that we had been doing up until that point, but this it doesn't work. It was not a good idea. It's not a good idea to take shortcuts, and I need to go back and correct this one. So for this one, it says, we're looking for the oblique asymptote of, this function divided by this term. And so what you need to do in these situations is we actually need to create some long division. And we're just going to divide here. We're going to take the numerator and divide it by the denominator. And again, if you use synthetic division, that's no problem. I'm going to use long division, but whichever one you prefer is fine. When I go to divide this, I look at how many times does it take x to go into 3x squared. I know that that's 3x, so I'm going to multiply this 3x by the binomial over here to get 3x squared minus 9x underneath. We're going to do a quick subtraction there to get 7x, because we get negative 2 take away 9 is positive 7, and then the 17 drops down just like doing normal division. I know that a plus 7 is going to be needed here to get the right coefficient, so I put plus 7 times x minus 3. And technically at this point we're actually done what we need to do, but I want to go through the rest of it to make sure we understand why it works. So what we get now is 7x minus 21 on the bottom, and this yields a remainder of 4. Now the remainder is actually not important to us for when we're giving the answer. But what actually does happen to the remainder? If we look on the side, you can see what's actually left over of this function, 3x plus 7, and then the 4. The 4 is a remainder, so it's still technically being divided by the x minus 3 because we weren't able to get rid of it. This is the equation of our oblique asymptote, this 3x plus 7 plus 4 over x minus 3. As we look at what this does as x approaches infinity, this last term here, the 4 over x minus 3 is going to become 0, right? This term approaches 0 over time because a very large x here means it's 4 over essentially an infinite number, which approaches 0. This means that what we're left with is really 3x plus 7, and so at either end of this function, the asymptote here is going to be this oblique asymptote of 3x plus 7. Now, just to quickly demonstrate what this one's going to look like when we graph it, we have 3x squared minus 2x minus 17, and then we have x minus 3 on the bottom, and our function was f divided by g. So we'll just hide the original 2. We'll shrink this down a little bit. Now you can see that here it has a vertical asymptote at 3. It also has a slanted asymptote. When I drew 3x plus 7, which is the answer that we're getting here, you can see that it produces the right picture for this asymptote. This line basically perfectly matches the curve and gives us the asymptote where it belongs. Okay. So again, the idea here is that this is the end behavior of the function. If we zoom out a few times, we can see that basically this line that we've created is indistinguishable from the function's behavior. Again, in the middle, other things can happen, but at the extremes, the function is going to be contained by this equation 3x plus 7.